Okay, so this is the second lecture on function composition. In this one, we focus on finding the formula for a composition of two functions with formulas. And so I'm going to go back here, and we're going to use the same f of g of x. So let's find the formula for f of g of x. Okay, and how do we do that? Okay, so we want to find a formula for f of g of x. Well, the way I like to do it is to plug g of x into the f formula. So f of g of x is 2g of x minus 3, which in turn is going to be, now it's very important to put g of x in parentheses. 2 times 4 minus x minus 3, which in turn, now we distribute the 2, and we get 8 minus 2x minus 3, which is going to turn into 5 minus 2x when we combine the 8 and the minus 3 together. So that is the formula for f of g of x. Now, the formula for g of f of x, because why not? Okay, so in this one, we do the same thing. In this one, we're going to say that's 4 minus f of x. Now we got to put f of x in parentheses, 4 minus 2x minus 3. Now we distribute the minus, so that you get 4 minus 2x, minus a minus 3 turns into a plus 3. And so that becomes, now we combine the 4 and the plus 3, and we get 7 minus 2x. So that is the formula for here and here. Now let's see if that really works. So right here it said that f of g of 0 was 5. Well, f of g of 0, according to this formula, is equal to 5 minus 0, which is 5. Let's look at g of f of 0. G of f of 0 is equal to 7 minus 0, which is 7, which is exactly what we got here. Okay, let's do the bottom line. I don't want to think it's sort of boring to do all these lines, so we can do f of g of 5, come on, type right, which is going to be 5 minus 5. Okay, is that what I get? 5 minus 2 times 5. Sorry. Should be 5 minus 2 times 0. It should be 7 minus 2 times 0. I just didn't notice that because it really doesn't matter. But in this case, it's 5 minus 2 times 5, which is equal to, come on, minus 5, which is exactly what we got here. And then f of g, and then g of f of 5 is going to equal 7 minus 2 times 5, which is going to equal minus 3. And that's exactly what we got here. So, as you see, this allows you to do the formula without having to pass through the two different formulas for f and g. So that leads us, so let's look at a little more complicated problem now. Let's talk about and we don't have to use f and g all the time, k of x is equal to x plus 1 divided by x plus 2. And m of x is equal to, okay, what do we want to do? Let's keep this one a little simpler. Let's just stick with f, okay, is equal to, let's stick with 2x minus 3. So what is f of k of x? Now, notice that f of k of x is a rational function, and that makes things complicated because we're introducing fractions. Fractions are scary. Now, so we're going to have f of k of x is 2k of x minus 3. Minus 3. But what is 2k of x minus 3 going to be? Okay, that's going to be 2 times this formula. Now, students have trouble often when mixing integers and fractions, and there's a trick to that. So this becomes 2 times that minus 3. But here we have a fraction and an integer mixed together. But here's the thing. Integers are really superheroes. They have secret identities. Every integer is really a fraction if you take off their mask. So 2 is really the fraction 2 over 1. And 3 is really the fraction 3 over 1. So now we have fractions and fractions. So now we know how to do this arithmetic. When we multiply two fractions, we multiply the tops and the bottoms. So that's going to equal 2 times x plus 1, or 2x plus 2 divided by 1. Oops, that's a 2. Okay, divided by 1 times, which is easy, right? X plus 2. Everyone knows how to multiply by 1, and we're subtracting from that 3 over 1. Now, to subtract two fractions. Now, remember at the very beginning of the class, I told you you need to know your fractions? This is why. This is when it comes up. This is the math you need. Now, subtracting two fractions means we have to make a common denominator. Okay? Denominator. Sounds like a professional wrestler. Now, what we're going to do is x plus 2 and 1, the common denominator is going to be x plus 2. So what I'm going to do now is take this guy and replace him by 3, okay, times x plus 2 divided by x plus 2. Now we have the common denominator, right? We don't have to multiply the x plus 2's by 1's because that's too easy. And now the only thing we have to do is on the numerator, we have to distribute the 3. So that's going to be 3x plus 6. Now, when we subtract two fractions with a common denominator, what we got to do is subtract the numerators. So this is going to be 2x minus 3x and 2 minus 6. Well, 2x minus 3x is minus 1x. And 2 minus 6 is minus 4. And we'll divide that by x plus 2. And that, now, you can't divide 2 into 4 any more than you can say that 13 over 3 is 11. You can't, you got to divide only factors, only the whole factors of the whole denominator, whole numerator. There are no factors of x plus 2 or minus x minus 4. So this is in lowest terms. You got to stop here. So let's see. So let's check our work just a little bit. What we're going to have is, let's start with f of k of minus 1. It's going to equal minus 1 plus 1 over minus 1 plus 2, which is going to equal 0 over 1, which is 1. 0, I mean. So k of minus 1, that is. Okay? So this is going to be f of k of minus 1, which equals that. And f of 0, so that's going to equal 2 times 0 minus 3 is equal to minus 3. So that's what f of k of minus 1 should be minus 3. Now, let's plug into this formula. And so that's what it is if we plug minus 1 into this formula straight. Now, let's try this. We're going to do minus 1. Okay, so we'll plug it into the formula straight. Another way, so we'll do minus 1 parentheses. Minus 1 times minus 1 minus 4 divided by minus 1 plus 2. And that's also going to equal minus 3. So f of k, so plugging it into this way, right, what we did up here, figuring out that and just plugging it into the formula gave us the same number, minus 3. So that gives us, so this is what we call a little bit of a check. It would be if I had my fingers around the right keys. Check. Now let's just run it the other way too. K, oops, there. K of f of x is going to equal f of x plus 1 divided by f of x plus 2, which is going to equal In this case, we won't need parentheses. 2x minus 3 plus 1 divided